Welcome back to the teardown of some real ancient telecommunication tech. Enjoy! What I have here is, and the younger people viewing this video probably won't even know these things, it's an NTBA, a network termination for ISDN base rate access. ISDN came into your house via the usual two-wire analog telephone line, which was of course no longer carrying an analog signal, but a digital signal. But inside the house you would use the S0 bus, which provided you a whopping 2 times 64 kilobits per second plus a 16 kilobit per second control channel. So you could make 2 simultaneous phone calls, digital phone calls with a bitrate of 64 kilobits per second, or do a data transfer to somebody else with a combined bitrate of 128 kilobits per second. That was enormous back then. So the analog two-wire phone line would be plugged in here, and these 2 connectors were for your house internal S0 bus. And if we look closely into that connector, we see, yeah, there are really only 2 pins that have some copper on them. The other connections are just empty. And that whole thing also had a connection to AC mains, because the S0 bus was powered. Yeah, it could supply some power to the connected devices. Not much, but it was enough to run those ISDN telephones. And for those who don't like plugging in stuff, there were also here some clamps inside. 2 clamps for the incoming two-wire analog phone line and 4 clamps for the ISDN S0 bus. So the connectors had 8 connections, okay, but they are RG45, I think, but only 4 were really used. And then you have 2 LEDs, one for power, 230 volts, and one for ISDN is active. And yeah, that's basically it. Nothing else. Oh, and the enclosure is made out of ABS, fire resistant, and the, here close up again, the clamps for your internal S0 bus, they were labeled here on the cover. Nice touch. I also want to mention that the technical documentation or documentation you got with these things was quite comprehensive. So they mentioned everything here. So the different standards it's working on, maximum length of your S0 bus, how much power the S0 bus can provide, 4.5 watt in normal operation, 420 milliwatts in emergency operation. Yeah, short circuit protected. How much that thing is drawing from your AC mains, and yes, voltage range it works 195 to 253 volts between 48 Hertz and 52 Hertz. Less than 9 watts consumption, and in millimeters the dimensions of the enclosure. So and the LED status, what they are indicating. Is there something blinking? No blinking lights. They either on or off. But now finally let's open that thing. Only a single Phillips screw here. Yeah, and that's a self-tapping screw. I mean, these things, yeah, well, they died sometimes, not often, but they did die. Some more snap-in action. Yeah, probably. It's feeling like it. Let me fiddle a bit. Before I fiddle too much, there are markings here on the enclosure where actually the snap-ins are. How cool is that? They definitely don't build things like this anymore. Come on, snap. That's it. Just wanted to point out the two light pipes in the cover for the two indicators for ISDN connected and power connected. And here on the inside are the two LEDs here and aboutish here. But now let's get that big bad board out of there. That was easy, just two snap-ins, very nice. Absolutely nothing on the back, so yeah, let's have a look on the top. But to understand what's going on the top side a little bit better, it helps to note that there are three distinctive isolated areas here on the bottom side. So that's the mains AC connector coming in here. That's probably for some power supply. Here the telephone line or AB lines are coming into that area, and in the middle, isolated from both, is actually the S0 bus area. And these three isolated areas are only bridged by a few parts. We have two switch mode power supply transformers here. One going from the mains AC side to the center S0 island or whatever you want to call it. And the other one coming here from the telephone AB line, supplying power to the S0 island in the middle. Remember, there was some emergency power function. If mains AC fails, you can still power things from the telephone lines. And the telephone lines in Germany carry about 60 volts DC, but very low amps, so probably just in the milliamp range. Then we have here a little optocoupler for feedback of the mains AC switch mode power supply, and two probably X or Y type capacitors bridging here from the telephone line island to the S0 island and from the S0 island to the mains AC island, just for noise suppression. And then we have this big fat transformer here, very complicated, a signal, ISDN signal transformer, and that bridges from the telephone line part to the S0 island part, so really to the digital S0 bus. But now let's start from the beginning with the mains AC power supply here. So mains AC comes in here, that's a fuse. These are two small resistors to limit the inrush current. I mean, we're talking here about a 7 watt or so power supply, but still inrush current limiting. We have here a MOF for transient suppression. We have a filter capacitor, that's probably an X type. We have a common mode choke, that's a common mode choke, and then a full bridge rectifier, and then some filtering. That's probably the switch mode power supply controller, and a freewheeling diode for the transformer. And then on the other side we have a rectifying diode and some filtering and some stuff probably to drive the feedback to the primary side. On the telephone AB line input side, we have a similar arrangement. So we first have a MOF for transient suppression, okay. Then we have, I think that's also a common mode choke. And this transformer is not part of the power supply path, okay. But then we have here a full bridge rectifier, some filtering, and some switch mode stuff driving the second switch mode power supply transformer over to the S0 digital bus island here. Rectifying diode and filtering. We already talked about that. Now for the signal side of things, and here is where this little transformer comes in that provides galvanic isolation from the telephone AB lines to this Infineon PEF8902 ISDN controller chip. And yeah, it also has a quartz here about 15 point something megahertz. And this is all situated on the telephone line island, isolation-wise, okay? And then from the telephone line island, we have this big transformer here, which is an ISDN S0 bus signal transformer going over to the S0 islands and supplying the digital RG45 S0 ISDN bus connectors here. And that's basically all she wrote. This dip switches here, micro dip switches, can switch in these two little 100 ohm resistors here for bus termination or not. Yeah, depends on what you want to do. I have no idea what these two dip switches do. They have something to do with the telephone line configuration. Yeah, that's it basically. I have here the block diagram of that Infineon PEF8902 chip, and you have here the telephone line transceiver. You know that because it's all with A and B. A, B, B out, A in, B in. And here you have the S0 digital bus transceiver with also 4 lines. And yeah, clock generation stuff, some control interfaces, and that's it. And on page 51 of the 80 plus pages data sheet of that chip, you see here like a resistor network for the telephone line transceiver pins. It's not just driving. And then you see here that galvanic isolation transformer to the actual telephone line. That was that thing here. On page 54, they show you how you need to galvanically isolate the S0 bus, where you plug in all your ISDN phones, from the transmitter and receiver pins on the chip. Well, little diode network here to avoid over voltages and some resistors. And here's the data sheet of that big blob signal transformer here to the S0 ISDN bus, a vacuum Schmelze, a German company, a T6407L554X006. And down here is the interesting part. Here you see it's two rather complicated isolation transformers for the S0 bus, for the transmitting and the receiving lines here, driven on that side by our little Infineon controller chip. That's it for today. I'm always a little bit flabbergasted when looking at telecommunication equipment, how solid and well everything is built, and there are no corner cuts. Input protection everywhere you look, and really solid isolation everywhere, and yeah, it's really fun to have a look at those things. Anyway, till next time, bye.